you're going to be doing 4 things. These 3 people solved this or simplified this incorrectly. So you need to figure out where person A went wrong, where person B went wrong, person C went wrong, and person C went wrong. But also simplify this and get the correct answer. So you're doing 4 things. Figuring out where each person went wrong and how do you know that, and then simplifying it to find the correct answer. You can do this on piece of paper, on your desk, with each other. You can use Desmos, your calculator, any of those. So I'll give you 5 to 8 minutes to work through that. Went wrong. Yes.
National first one.
Do I just circle where they went wrong? Well, keep these students out.
And what was wrong with us?
They said that -3 power 2 is -6 and 8 is not.
Correct. So I drew a little arrow to show their end result mistake. So yes, they multiplied here instead of squaring. Maybe you want to do B. You want to do C? Sorry, you had already. Max can do C. Desmond, do you want to do the answer? Desmond, want to do the problem? Yeah.
Basically, it was -3 squared, but he put positive. So he needs to do it because we did not.
Okay. Do we agree or disagree with this?
No, it's in parentheses, so it has to be positive.
So this is the positive answer. This part is correct. Do you have something different?
Why you learn?
We also put a positive instead of a negative, but that's correct.
Right here. Yeah. So this should be positive, so that part's fine. But when you said -9, this is what you're talking about. So they took the absolute value and got a positive, yes, but then they didn't bring down the other negative, which would have been a minus. Yes. Okay, and then Max, and C. Okay, then Bubby, you want to do C, and then Max, you want to do the answer?
So here they
You want to look back at what you wrote?
Yeah.
So you can come back to that if you want. Someone else want to say where we went, Barry?
So when they did,
So here, they took the square, so what we said earlier, but the opposite. Here, they took the square and it shaped a positive, not a negative 9.
Like the ABCs.
Right? So we all should have gotten those 3. Anyone want to come show the correct answer? You can just do it in the open space. So that you don't have the arrow, because that'll be sort of fast. If you want to put a circle on the arm, and you have it. You see a very little arrow circle like this and popcorn. Click. Yes, 17 was correct, so I'm going to add in a couple things because we should be putting this in exactly as we see it. Again, we could have done some of these at the same time. Squared the -3, multiply these, multiply these, multiply these, and then started combining to get 17 was the correct answer. Questions on that? Okay. I'll let you hold on to the markers for now. Everyone look at your course calendar. I just want you to take note of specific dates.
Christmas.
You have Delta Math due on Friday for what we're going to do today on 2 different Delta Maths, so that's 2 due on Friday. Some due next week, and then so on and so forth. Look at your quiz date, your test date, your flex day date. Okay. Keep those in mind as we move forward. If you lose this, these dates are on Canvas. This paper is also on Canvas. You can look at those dates anywhere there. They're also on this board, the top left corner. All of those dates are up there as well, so you have to find your specific class for all of those. So keep in mind those dates. As dates get closer, I'll send out reminders on Canvas as well as put it up here. All right. Today, we're going to be starting our new unit. We have Monday off, yes, for Yom Kippur, that holiday, yep. Today we're starting a new unit on solving equations. Some of it will be new, some of it will be reviewed. But everyone should have notes that look like this. Put that in front.
Oh. There has to be a vowel.
Alright, so first question. If I said, what is the solution? Okay, so I was going to say, what would you say? The result or, sorry, sure, either or. The result or answer to a problem. So now that we know what a solution is, this next part we're going to determine if the following are solutions or not. So, for number 1, let's say I solved this equation, 13x minus 7 equals 58, and I got 5 equals, or x equals 5 as the answer. How would I know that this is the answer? How could I check myself? Ella? So I could put 5 back in for x. You don't need to draw these arrows, you can if you want. And figure out, is it true or is it not? Hold that up. You already did, hold that up. Alright, so this is kind of like when we were evaluating x equals something, we put it back in, we're doing the same thing, but now it's with solving. Alright, so put 5 in, make sure you're using parentheses. Multiply 13 by 5, how many do you get?
58. Oh, 13.
65, 65. And then if we subtract, 58. So we can say this is a true statement. This equals itself. So this would be the solution. This is a good way to check yourself when you are finished solving. Put it back in, see did you get the correct answer or not. If you did, you know you can move on. If you didn't, something's wrong, you gotta go back and fix it. Okay. Number 2 shouldn't work because 5 works, negative 5 should not work, but we're gonna test it anyway. So put negative 5 in and let's solve that. We have negative 65 minus 7, negative 72, which is not equal Good way to check yourself. Bless you. You put the number back in. You don't get the same number. This is not your solution. Somewhere you went wrong. You got to go back and fix it. Okay. Questions on this part? I'm going to show you how you can do this in the calculator. So in the calculator, I need everyone to do this. You're going to type in, we'll do the first example and then the second. 13, parentheses, 5, and parentheses, minus 7. Then we want the equals. That's in text above math in blue. So second math equals to B. And then hit enter. The calculator is going to play a true-false game with you. 1 is true, this is your solution, this is your answer. 0 is false, this is not your solution, you have to go back and fix it. But it won't show you where your issue is. So I'm going to do this again, but with the second example, put in negative 5.
Do we hit equal?
Yeah.
Yes. Why does it say 1? Oh, okay. I'm understanding.
Second math for equals, 58. 0 means it's false. Something in there was wrong, but it's not going to point you in the direction of this piece is wrong. You just have to resolve it.
That's so amazing.
1 means it's right, 0 means it's wrong. Okay. So you can use this, or you can just put the number in and do it by hand, either or, to help you figure out if you get the correct answer or not. Okay, before we go to lunch, I want you to try numbers 3 and 4. See if those are or are not solutions. And then before we go to lunch,
Okay.
was number 3 a solution or not? No. Okay.
I still have the same answer.
And then what about number 4?
Yes.
Do we need to see either of those?
Number 4.
Okay.
Sorry.
So if we put negative 34 in number 4.
I don't know how to do the
If
fraction.
I'm doing this, that means you guys are quiet.
See, I really Can you actually do that?
So I need everyone's voices to not be talking over mine. Okay. So this would be negative 17 plus 5 equals negative 12.
It's not in the fraction.
How about that? Let's get back to this part. If we divide. We should get negative 7. Okay, other questions on this part before we move on? Okay, on to the next page. So, now you know how to determine if solutions are solutions or not. This part is talking about properties of equality, and what that really means is what you do to one side, you have to do to the other for addition, subtraction, multiplication, division. Not so much, bless you, not so much distributive property. That can be done on both sides, but it's really you distribute to simplify. Not really something you do to both sides. Alright, so in these examples, these are solved for you already. We're just determining what happened. What property did they use to solve from step to step? So the first step is always going to be given. That's going to be your original. From step 1 to step 2, what changed? What did they do here? They multiplied by using the distributive property. Okay, and then step 2 to step 3, what did they do next? So if I subtracted what first? So if we subtracted 18, would that give us 8? Added. So they're doing the opposite. They added. So that would be your addition property of equality. I'm going to show that. Okay, right. All these words. POE for property of equality. Alright, and then step 3 to step 4. equality. Do you have questions on any of those from example 1 before we move on to example 2? Yes, sir.
What did you do for the first one to with the x and x minus 9?
From here to here?
Yep.
Yes, I did not know that. Multiplied it to both of those. Other questions in example 1? Okay.
So on the topic of solutions, we could basically write to the one of nine.
Yes. So this will not be something that you'll need to remember this property is called this or the definition. You'll just need to know how to apply it.
And what is distributed probability?
Just when you have something outside of parentheses and that gets multiplied to addition or subtraction, over addition or subtraction. Right? Example 2. First one is given. What did they do from step 1 to step 2? Added 10 to both sides or subtracted? So your subtraction property of equality. And then from step 2 to step 3, they multiply. You were already dividing, so they multiply on both sides. Questions on example 2 before I have you try example 3? Go ahead and try example 3. I'll give you like a minute. Check your answers with mine. Anyone get all 3 correct? Good. Alright, if you didn't fix it, do we have questions about any of these? Okay. So as I mentioned earlier, not that we need to know the definitions of these, but we need to know how to apply them. So go on to the next page, once you have that written down.
What is that purpose of well?
It just means what you do to one side, you have to do to the other. Okay. Alright, so this is kind of a repeat question, but also not at the same time. If I asked you, what does it mean to solve an equation, what would you say? Okay, you find the equivalent, the smaller, maybe equivalent, equivalent of, find the answer, okay. So kind of like what we talked about before, so to find the answer, the solution, but by using our properties of equality or the inverse operations. I'm going to put that all in one sentence. To find the solution or answer, by using inverse operations. And then just to make sure we're all on the same page, what is the opposite or inverse of addition? What is the opposite or inverse of division? How do we undo, or what is the opposite or inverse of squaring something? Square root. And then cube root would be the other. So think about this like, if I have 3 squared, that will give us 9. The square root of 9 is 3. They undo each other. Same thing with cube and cube root. 2 cubed is 8. The cube root of 8 is 2. They undo each other. Alright, take a second and read these directions. These are your go-to steps when solving equations. So like if you get to a problem, you're not sure where to start, most likely it's going to be one of these steps. Distribute, if you have parentheses, something outside of parentheses over addition or subtraction, then you can distribute. Don't just randomly bring in numbers and distribute. Combine like terms, if possible, only on the same side. We'll talk about what happens when they're not. Move the constant by adding or subtracting, and then get the variable alone by multiplying or dividing. So, I want you to look at this page, look at all the different problems, find any you think are complex, maybe you wouldn't know where to start, you want to do together, find those and say those out loud. Any others? 4. 2. Okay. We have a good list right now, so let's go through these. If we have others, we'll come back to this. So we'll start with number 2. Our goal is to get m by itself. We have to get rid of everything else around it. Think back to when we were writing out the properties of equality, they usually got rid of whatever was not directly attached to the variable, so the 2. And we're using our inverse operation, so doing the opposite. So what do you think we would do first?
Subtract 2.
We have 8 equals m over 4. Then to get rid of 4,
You have to multiply.
multiply both sides by 4. So these 4's cancel, and we're left with 32. If you wanted to double check that this worked, you could put it in a calculator or just put it in. 32 divided by 4 gives us 8. 8 plus 2 is 2.
Where do you get 4 from? 4 multiplied by 8. There's 4.
Right here. In order to get rid of this 4, we have to multiply. So we're already dividing. But what we do to one side, we also have to do to the other. Your property of equality. You can't just multiply one side by 4. Okay. Number 3. What do you think would be our first step?
So 25.
25. Now, if this were like a regular problem and it just said 2p, how would I get rid of the 2 in general?
Multiply.
If they were already multiplying, we would
Divide.
divide, yes. But this one has a fraction. In general, we don't like dividing fractions by fractions. So what we do instead is take this fraction and flip it. It's called the reciprocal, and multiply it on both sides. I'm going to show why this works here in just a second. So multiply this, and tell me what you get. These are going to cancel because it's a multiplicative inverse. This becomes b, or 1b. I did not say this, so I'm going to say it now. I may have mentioned this earlier on in the year. I may not. Anyway, because you're in an advanced class, some of your quizzes/tests sections will be no calculator. Some of this section will be no calculator, so it'll be half and half. Some will be calculator, some will be not. So as we're practicing, try to not use your calculator for everything. Some of it will be calculated, but some of it won't. So practice not using your calculator for every single thing. Right? So now I'm going to show why this works on a calculator. If we had divided, one, we would have had to make sure it was in the fraction format. Usually when we divide, we get a smaller number, but this one gave us a bigger number, which means what the calculator actually did was multiply. So both methods work, but if you're dividing by a fraction, you have to make sure that you put it in this specific method or that you put it in a fraction within a fraction, which was weird. And you have to do it a specific way. But that can get messy. That's why multiplying by the reciprocal is a better option. Yes.
Why did you multiply 2/3 to be second and then dividing by 2/3?
So this would have been what we actually did. This is what the calculator is actually doing. That's why the answers are the same.
So it doesn't actually make any difference if it's 2/3 or...
It does, because we can't multiply by 2/3. You wouldn't get the same thing. You couldn't divide by 3 times, because you wouldn't get the same thing. So whatever the actual fraction is, you could divide by that fraction. But if you're flipping it and multiplying, you have to flip it. It can't be the same. So the order matters. Other questions on that? For number 4, what would be our first step?
Plus 3.
Add 3 to both sides. And then
Divide by 6.
divide by 6. When you do that, you need to simplify this fraction. Get it in its simplest form. What would that be? As a fraction. 5, not thirds, but you're close, right? 5 times. So some of your answers will be fractions or decimals. Check your work, put it back in, see does it work. Sometimes you will get fractions or decimals by accident, so double check your work. Right? Questions on 3 or 4? So if you did this like 15 divided by 6, instead of as a fraction. Number 8. What do you think would be our first step? Distribute. Yes. Multiply the -3 to everything inside. We have y minus 6y plus 21 equals 76. Okay. And then what?
Subtract 21.
Okay, we can't subtract 21, but look back at your steps, your rules. What was the next step?
Combine like terms.
Combine like terms. So do exactly what it says, 1y minus 6y. Make sure you're not doing the opposite here, you're doing exactly what it says, just like with simplifying. Then we can subtract 21. Now, if you had subtracted 21 first, that would not have been an incorrect step. As long as you eventually combine your terms, that's one where the order really doesn't matter. Great, and divide. What would y equal? So I'll do this in the calculator for this one, but not for 9. If I were to put this in the original,
You have to distribute.
someone read that problem off to me. Y minus, sorry, y minus
minus 7.
Oh, minus 7
Yep. 7.
equals. So that was the correct answer. But if you have multiple variables, you have to put it in multiple times. So be careful with parentheses and things like that. Okay, number 9, what would we do first?
Distribute.
Yes. We have 4m minus 15m minus 50 equals 126.
Combine the terms.
Yes. We have negative 11m minus 50 equals 126.
Plus 50.
Add 50 to both sides. And divide. So the m equals
Negative 16.
Were there any other questions on this page that we wanted to see you go over, have questions about before we move on?
How do you know when you're answering fraction? Like, is the number just not wholly?
How do you know if it would be a fraction or not? I could put this back in, like how we just did this one, double check this one, put the number into all of the m's for this problem, and it should equal 126, and you'll get a 1 in your calculator.
So if the one's the answer is right? Can we do numbers?
6 is a little different because there are 2 different ways to solve it. So I'm going to show you one way. One is dealing with the fractions, the other is getting rid of the fractions, and then you can choose, if you get a problem like this, how you wish to solve it. So if we're dealing with the fractions, we need to combine these 2 fractions by adding them. The only way to do that is if we have common denominators, so just think of a number that these both go into. 6 works. So I can multiply this by 2. What I do to one piece of the fraction, I have to move to the other. And then multiply this by 3, and same thing here. And then change those numbers.
So now you combine the terms.
Now we can combine the fractions. And then combine them. Now, and then in this case, you have 2 choices. You could multiply both sides by 6 and then divide both sides by 7 in 2 steps. Or, because this is the same as 7 over 6x, these 2 are the same, I can take this and flip it and multiply it on both sides. Multiply by the reciprocal.
So when you multiply fraction, you split it.
When you divide by fractions, you flip it. So what would x equal?
6.
If we put that back in, 2 times 6 is 12. 12 divided by 3 is 4. 6 divided by 2 is 3. 3 plus 4 is 7. It works. Okay. Alright, so I'm going to show you the other way. So if you have space somewhere, either on the next page, on that page, somewhere, write the problem again, and we'll do it one more time, but a different way. So the first time we dealt with the fraction. This time, you see this problem, and you just blank and don't remember what to do. You just want to get rid of the fractions. we need to multiply this entire side by something that these both go into, so the 6 still works. Now, in the last problem, we didn't have to multiply the 3 and the 2 to both sides because we were just combining fractions, adding fractions together. So the properties of equality didn't apply. This one does because I'm multiplying to the entire side, so I can multiply this by 6 as well. When we multiply by 6, this is like 6 over 1. So we're just multiplying to the numerator. It's like distributing, but just to the numerators. Now we still have fractions, but not for very long, because we can simplify these to get what? 4x plus 3x. Now the fractions are gone. You can combine my terms and do it. So get the same thing, just in a different method. So whichever method makes more sense to you, use that if you see a problem like this in the future. Questions on this? Take a second. We've been sitting for like 30-ish plus minutes. Stand for just a second. Stretch your limbs. Wiggle all your fingers and toes and arms. Everyone stand for just a second. Everyone stand for just a second. Haley, Zara, Nathan. For just a second. Stretch and then you can sit right down. Okay. On the next page. We're not going to actually do these, but I am going to walk you through how this could help you if you so choose to use it. This really only works if you have a two-step equation. So like a number times x and then another number adding or subtracting equals something. It only works if you have that type. If you have more than that, this won't work. So the steps here explain the equation. Pick a number as your variable, multiply it by 7, add 5, the result is 26. So this explains the equation. The answer is how we start to solve. So we start at 26, we're subtracting 5 from 26, we divide both sides by 7, then what is the number we're trying to find the solution. The checkbox is doing the answer, part of it. So we start at 26, we subtract 5, get that answer, divide it by 7, and then the number would be whatever we get. The last part of the check is putting that number back into the original to see the total. So if that helps you, if that works for you, if you want to use that, feel free to do that. If that didn't make any sense, ignore everything I just said.
What does it mean by pick a number?
That's your variable.
Oh.
Okay, go on to the next page. Okay. So now that we've talked about some solving, we're going to get into, this is your fourth objective, being able to solve real world problems. So we're going to skip number 1 and come back to it and start with number 2. The first thing you should be doing with any real world problem is read it and then find important information. So let's read it first. Read it with me. To mail a first-class letter, the U.S. Postal Service charges a flat rate of 53 cents and 18 cents for each ounce. It costs $2.69 to mail your letter. How many ounces does your letter weigh? What do you feel is important from this? We're going to circle, highlight, underline anything you feel is important. Yes. Numbers are important. Go ahead. For each ounce. That's also important with this. The question is always important. What is 53 talking about? Point 53 is talking about the flat rate. Okay. So before we jump into the next part, I'm going to explain what a couple of these things mean. Flat rate, or if you see like a one-time fee, that means no matter what, no matter how big or small, how much your letter weighs, you will always get charged this. So if your letter weighs 100 pounds or 0 pounds, you're still going to get charged 52 cents, no matter what. It's just the way the post office works. I don't think it's actually 52 cents anymore, but for each, if you see those words or the word per, P-E-R, that means whatever that number is going to go with some variable in our equation. Now, in order for it to go with the variable, we need a variable. So you can pick whatever letter you want. I would say stay away from O, because you might confuse it for a 0, and T, because you might confuse it for a plus. For the most part, everything else is starting. Pick whatever variable you want, and then look at your question. The question will tell you what we're looking for, what we don't know. What are we looking for? How many ounces? So when we write or define our variable, we have to be specific. We can't just write ounces. We need to know what don't we know about the ounces. So number of ounces. Right. Once we have defined our variable, then we can start to piece together this equation. So we can start with the total. Because we know that's what it's going to equal. And if we have a total, what operation are we using? Addition. Which means we're going to be adding these two things together. How you put them in does not really matter. And then because this is for each, the variable is going to go with that. So now we have our equation. We have just translated this word problem into an equation. And now we can solve the equation. How would we do that? Subtract that, tell me what you get. Divide both sides. And what would we get? Double check that. It should be 12, but 12.
Oh,
what?
sorry, 12.
12 ounces. There we go. We have to be specific with our answer as well. If you just put 12 on your quiz or your test, I'm going to put 12 what? You need to put labels, especially if they're real world problems. Okay. Do we have any questions on how we found the information, set it up, solved it, got the answer? Z. There. Yeah. Is it Z? I don't know if that looks better. Okay. Now we're going to go back and do number 1. Alright, so I'm going to go ahead and read that. The length of a rectangle is 3 inches more than the width. The perimeter is 30 inches. Find the dimensions. What is important there? The length. What about the length? It's 3 inches more than the width. So that's important. And then
How much the perimeter?
perimeter is 30 inches. And we're trying to find the dimensions. Meaning we're finding both the length and the width, not just one piece. Right? So you do need a little bit of background information. How do we find the perimeter of a rectangle? So length times width is area. You add up all the sides, or more specifically, You can use this equation, P equals 2L plus 2W. It's the same thing as adding up all the sides, but it's more specific. You're taking the length, multiplying it by 2, because there's 2 of them, adding it to 2 times the width. Okay. So when you define your variables, you don't have to be specific with these. You do have to define both of them, because there are 2, but it'll just be length and width. This one's going to be different than how we set up the last one for a couple of reasons. Let's make an equation for the length. So length is L equals 3. Right, so 3 and then what else?
W.
What about W? Correct. So all the translation stuff we just did has not been lost. We will still keep using that. So L equals 3 plus W. We know this is our equation for perimeter. We also know our perimeter is 30 inches. So let's rewrite that. So here we have 2 different equations going on. And because of that, we know this is our equation for L. We're going to take this equation and put it in for L. So kind of like when we were evaluating, we put in a number. But in this case, we're substituting an entire equation into another equation here. So then we can rewrite. 30 equals 2 in parentheses, 3 plus W, plus 2W off the end. So now we have our equation, and now we can solve. What would be our first step? And then 6 plus 4W, and then at 6, we have 24 equals 4W, and then divide, so the W equals 6 what? 6 inches. Okay. But that's only half of it. It wanted us to find the dimensions. We only found half of the dimensions. So we still have to find length. How could we use our width to find our length? Add 3 inches. So we're going to take this and put it in for W. So we need to show this and then figure out what L is. So if we were to put 9 and 6 back into the perimeter equation, 2 times 9 is 18, 2 times 6 is 12, 18 plus 12 is 30. So it works. Yes. Say that one more time.
Where did we get B4?
Where did we get 24? We subtracted 6 to 30.
Oh.
Do we have any other questions on how we set this up? Got the answer? Yes, that's the fourth of it. Any other questions on how we set this up? You're confused about anything in that? Because we're going to do another one. Go to the very last page. The back of that last page. And then the bottom of that last page. Section that says perimeter of a rectangle. These are all the same. They're all similar. But I'm going to let you guys choose 9, 10, or 11. Which one do you want to see, do, or go over? I heard 9 and I heard 10. So if you're a 9, raise your hand. 1. If you're a 10, raise your hand. Okay, majority rules. Alright, so 10. Same as before. Let's read it. The length of a rectangle is 5 inches more than 4 times its width. If the perimeter of the rectangle is 90 inches, find its dimensions. So what's important here? The length. What about the length? 5 inches more. 5 inches more than 4 times its width. Higher piece is important. And then what else? Perimeter of the rectangle is 90 inches. And then we're looking for dimensions. So just like before, we can write out L equals length, W equals width.
You actually have to write it in a test, L equals length.
Yes. You have to define your variable. It's one of the points. Okay. Then we can make our equation for length. L equals plus 5 plus 4. Right? We know that equation for perimeter is 2L plus 2W equals P. We know our P is 90. So then what are we going to do with the equation for L? Put it in the other one. So rewrite it. 90 equals 2 times, in parentheses, 5 plus 4W. Don't forget about the 2W that was already here. Now you distribute. Solve it like a normal problem. 90 equals 10 plus 8W plus the original 2W. Combine like terms. Get rid of 10 by subtracting. And divide. Tell me what W is. Eight what? Inches. There we go. Okay, last piece. We have to find the length. How would we do that? Not 5 and 8.
5 plus 4 times 8. Here we go.
We have to put it into the entire thing.
It's so far. It's like
So put that into the entire thing. Figure out what your length is. Seven what?
so what?
Do we have any questions on how we set that up, solved it, got the answer?
Huh? 32.
The last thing you guys are going to do is go back 2 pages.
Like go back 2 full pages or like 1?
Okay.
The page we were already on.
The real world
The
problem.
real world problems, yes.
Oh, Lord.
And I want you guys to do number 3. You're going to do all of the parts of number 3.
What?
Couple things.
Counter offer.
Make sure that you're looking at the numbers. The first set of numbers goes with blue. The second set of numbers goes with red. If you want to color code those, you can. Part A and Part B ask you to write an equation about total costs, but it doesn't tell you like what the total cost is. So at the end, just put equals total. Just write equals the word total. Okay. I'm going to show you one thing, and then I'll let you work. You can use each other, you can use your notes, you can use your calculator, you can use Desmos to do these. To use Desmos, just in case you didn't know how to do this, you can check yourself in Desmos by putting in any equation. It has to be with the variable x. Whatever equation you put in here will give you a line. Whatever that line's x value is will be your answer. So the answer to this problem is x equals 1. It's a good way to double check yourself as you're doing this. Right? So use each other, use your notes, use your calculator, use Desmos, work through all of 3. I'll be coming around if you have any questions. Let me know if you need my help. Also, before class ends, there is additional practice on solving and word problems up here. Feel free to grab those whenever. You have this time to work.